This is going to be the February security talk. So this week we're going to be focusing on Sigma, more about like operationalizing it necessarily than how to write rules and stuff like that. So I think the operational part of it is something that a lot of teams miss. It's a little bit more than just running the translation itself. There's a lot of configurations and customization that you can do to really get the most out of Sigma. So that's what we're going to be focusing on today. So let me just get going. All right, so before we get going though, promised last talk that we would bring up how to solve the challenge 4, which was first completed by Dev Dua. So congratulations to him. And let's take a look at the problem here. Click. So again, all of these are on my personal GitHub, and you just go to challenges, and challenge 4 is there, and it says, as in challenge 3, there's a base 64 encoded Python script. This time the author has improved their password verification by using MD5, and the script contains a secret message. So the solution to this was to use a known plain text attack. That's why the hint is the secret message is a URL and challenge 3's answer, because this will give you the plain text you need to basically reverse the encryption. So if we take a look at the actual challenge code now, this is the challenge once you decode the base 64 and compression using something like CyberChef. You should get the script in front of you, and you can see that it takes a password. It changes this passwords into decimal here, decimal values, and then does a little bit of modification to the secret, just like in challenge 3 if you tried challenge 3. And then it performs a check to see, does the modified password match this MD5 if you take an MD5 sum of it. And that's happening right here. So if it matches, it does the decryption. So basically the issue again is that, and it's common in cryptography, right? Like if we send the same message over and over again and we are using the same key against it, we can kind of start to guess what the first couple bytes of that message might be. So think about it. It happens a lot, especially with file formats today. Like certain files start with similar headers over and over again. Certain protocols like HTTP start with the same bits and bytes over and over again. So it's something that happens a lot. This known plain text attack is very strong because of that. So that's kind of what this is emulating. And what you can do is, if you know the that it's URL, you can guess, hey, I think if I put in HTTP, I think the first couple bytes are going to be HTTPS, for instance. You can start to decode this this challenge. So let's run HTTPS in there. This is the solution. So what it does is it takes the script to solve it takes, or there's actually more than one way to do this, but this is how I wrote the solution. The script, sorry, that I wrote to solve it, it takes your guess for the plain text, and this could be brute forced if you really wanted to, but I think I made it pretty obvious with giving you the URL as an example. So we get the decimal values of the guess, and we just XOR it with the known ciphertext, which is here in the previous script. And then we make we undo the manipulation. So instead of addition, we just subtract it. And then we print our guess and take a look at what it could be. So if we run this script, you'll see that it takes the guess and it pops out the password, which is "Oh Happy Holidays," in obscured a bit. So we can take that, put it into the challenge for ask us for the password, and it'll say it's correct and give you the link to I think it's a link to an old picture of a family around a Christmas tree, if I remember. Open, why not? Yeah, the Dickey Christmas tree. So that's the secret message. So it's been a long time since Christmas, but I hope you guys had a good one. This challenge is a little bit stale. Anyways, so again, as every time someone solves one, or every month, we try to release a new challenge. So this time it's challenge 5, and this one's a little bit obscure. There's no real explanation of what to do at all. It's just kind of self-explanatory. Once you take a look at that file, I'm pretty sure that you'll immediately have some ideas of what maybe the challenge is. So that's for the challenge. So moving on. So if you're not aware, there was a pretty critical vulnerability in VMware vCenter with POC code because it's so trivial, released within the last day. And this CVE is now available, or a detection for it is now available on TDM, and we'll probably be pushing that detection to the public Sigma repo as well. But basically, it's very alarmingly trivial to exploit in VMware vCenter, and you just post any arbitrary file to this URL in vCenter, and a file is uploaded. So the main way people are getting execution from this is uploading web shells, but you're not just limited to that. You can upload SSH keys and then SSH into the host. You can upload link files and hope someone clicks on them, or put them in auto runs locations. You could do something like DLL search order hijacking. So once you have arbitrary file upload, there's a million different ways, right, to get execution, especially if you have arbitrary upload with a privileged account, which is kind of the case for this VMware vCenter vulnerability. So let's take a look at that. On TDM quickly. It's surprising, like this vulnerability, it didn't come with like a brand name. So it hasn't really like blown up, even though it has such a high score. People are talking about it, but not as much as if it was called vCenter Strike or something like that, like vCenter Own. Then everyone would be like, oh, watch out, be on CNN or something. It's kind of amazing what marketing can do for these serious vulnerabilities when they brand them. But yeah, it's really simple. All we're doing is we're looking for a post to that directory. So yeah, it's pretty easy. So a lot of times, like the more trivial exploits are actually easier to write detections for, because most of the time they have to do with like web exploits, and we get a lot of telemetry, right, as defenders potentially about what's happening to our web servers because of things like WAFs and reverse proxies and just logging web logs, which we always recommend. It's a low-hanging fruit data source for pretty much everyone to gather. So moving on to the main meat of this month's talk is Sigma. So let's start diving into this a little bit. So Sigma, what is it? It's just a way to express detection logic, okay? And it's done in a way that is friendly to do things programmatically with it, right? To automate certain aspects of detection engineering. So you can pass this rule to a program, and it spits out a translation for your SIM. And it's also like super human readable. Every rule is, let's go back to the TDM rule here. So like every rule is very simple to understand. You just have to read it. Whereas certain rules, like if you write your content into like XPack Watcher or something like that, or even like Yara L from Google Chronicle or something like that, they can be like really difficult and to understand as just a regular person who isn't in them every day. So with this with this Sigma language, which is in YAML, you can just look at it and kind of understand what's happening. So that's like one of the primary benefits of it. And you can track more things about the rule than maybe your SIM allows. So a Splunk SPL query, for instance, unless you put comments in there, it doesn't really have a way to track metadata about the rules, or if you like add eval statements and stuff like that, or Lucene queries for Elastic. It doesn't let you have comments in there, so there's no real way to like say, hey, this is what this purpose of this rule is. Here's the reference if something happened. Here's MITRE attack. Like there's a lot of additional metadata we can append to rules that maybe our SIMs don't allow us to. You can avoid vendor lock-in, and MSSPs, XDR folks can gain a lot of benefit from this as well, because if you have this meta language you're writing your detection logic in, if you're on Splunk today and you're moving to Sumo tomorrow, or Humio, or Azure Sentinel tomorrow, if you have all your rules written in this meta language, it's just a click away, theoretically, and you have a new rule written in your new backend instead of going in and manually converting SPL queries, Lucene queries, KQL queries to another language. So with MSSPs, XDR, CSSPs, if you're in the government or military, you guys have a lot of benefit too, because you're dealing with multiple backends all the time, and even like large companies, or maybe every company anymore, who's using Azure. If you have Azure, you have Sentinel. Maybe you don't have access to it. If you don't have access to, if your company's using Azure, you have access to Sentinel. If you haven't given, no one has given you access to Sentinel, I would ask for access to it. Just a tangent. A lot of people, there's a lot of value in there, and there's a lot of logs in there that probably aren't being forwarded to your SIMs. And Microsoft releases, like the community releases a lot of content on their GitHub that you can use natively in Sentinel to find evil. So a lot of the like SolariGate content they wrote, they were like pushing out probably a couple dozen rules related to SolariGate that you could just run natively in Sentinel. Anyways, not to go too much on a tangent here, but anyways, if you're MSSP XDR, you're dealing with multiple SIMs. So if you have one meta language, and even if you have different SIMs with different customers and they're using different schemas, and they're using basically if they're using multiple customers using the same SIM, but it's different schemas, you can take care of all of that theoretically with Sigma configurations, which we'll be talking about later. So sorry for going so quick here, but I just want to make sure that we have time to get into the meat and potatoes. So Thomas Patsky, Florian Roth are the main authors and contributors to the project. And of course, these rainbow people here stands for the community, because there's a lot of people, especially folks writing rules and configurations, and occasionally a backend or two. But actually, most of the backends in Sigma at this point, I think, have been generated and submitted by SOC Prime. So that's one of the main ways that we contribute to the Sigma project. So we have a team that basically their whole job is to improve backend support for Sigma. And yeah, licensing is boring, but it's really important because every Sigma rule has a license that kind of tells you what you can or cannot do with the rule. So basically, if it's a way of giving credit to the original author. So if you use a Sigma rule, they're just asking you, hey, give kudos to the author by mentioning them in the rule that you created, and give a link back to the Sigma project. So the increased sharing of rules and stuff like that can go on. The Sigma tools is in LGPL. Basically means it's open source. You can use it freely, and the Sigma specification is a public domain, and that means that you're free to use the Sigma specification for however you want. But those are the restrictions on licensing. Mostly, you only have to worry about Sigma rules, probably. But I'm not a lawyer. Guess I should have said that first. Anyways, expectations. Sigma is not a perfect project. There's some things about it that are really useful, some things about it that are misleading sometimes. So there's no sim that natively supports Sigma today yet. That would be really awesome if we didn't have to worry about Sigma as like a meta language, but in the translations, and if vendors just said, hey, we just natively accept Sigma, you can upload your Sigma rules and it goes into our native language and you don't have to worry about running your own translations or anything like that. No, from my understanding, I haven't seen a sim do it. If maybe I'm wrong. You can post it in the Q&A, which is open. So it's not a false positive free library, right? And that doesn't exist. There's no such thing as false positive free. If someone tells you that they generate alerts that are always true hits, then they're probably not covering a whole lot, because there's kind of a general rule. Maybe it could even be considered a law in detection engineering that the more narrow and specific your use case is, the less you can see. Basically, it's kind of like what is that called? And oh man, I hate when I have like an idea, but I can't express it. Anyways, it's kind of like that thing in quantum mechanics. If the smaller you try to look at a particle, you can't. You can either tell where it is or how fast it's moving, but not both, right? It's kind of like that. With Sigma, it's the same thing. Like as you get closer and closer to identifying true evil, the less and less you're able to detect with that rule. So if someone says all of our rules, they only never have any false positives, then their scope of what they can possibly detect is very narrowed. All right, put simply, I guess, hopefully. Translation problems exist. Sigma is like a meta language, and the backend translations aren't always 100% perfect, and it's something that is continuously evolving and improving. And some of those translation problems might seem to exist, but later we'll talk about backend options, which can help you solve some translation problems. And then use cases are limited. What does this mean? It means there's only, in the public repo and even in TDM, right, there's only so many use cases that are covered by Sigma. Sorry, when I say TDM, I mean Threat Detection Marketplace, which is SOC Prime's marketplace for content. But there's only a certain amount of rules and coverage in general, but then there's also a limit on the types of content that you can express as a detection engineer. So 90% of the content in there is, if this field contains this value, complain, right? That's like 90% of the logic. You can do some aggregations with Sigma, and you can even do some chaining, but it's limited to like it's pretty limited to exactly what you can do. So there's no like super advanced logic like you can do in KQL or this SPL, Splunk processing language or something like that. Anyways, moving on. So here's like how it works really is you have a Sigma rule. And here's an example rule that just is looking for, I guess, a canary account without it just contains the word canary. Hey, if someone if you're using canaries, I want to call your account canary, but for the sake of this example, that's what I went ahead and did. And then you have SIGMAC. And SIGMAC, there's terms that can be conflated here because there's SIGMAC, the tool that does the conversion, and then the configuration is also commonly referred to as the SIGMAC. So that can get very confusing at times because sometimes people mean SIGMAC to mean the backend they're converting, the backend converter, the actual Python code, and sometimes people use SIGMAC to mean the actual config. So I'll try to be as explicit as possible and obvious as possible as we move forward, but when I refer to SIGMAC, I probably mean the converter plus the config together to get your backend. And again, it's just Python code that takes the YAML and makes it into the query language or the search processing language. That's what it is. There you go, SPL, search processing language, right? For your backend. So then you have your backend query. It doesn't necessarily have to just be a query. Like you can convert to Sigma rules. You can convert to sysmon configurations. You can convert to, basically, in theory, you can convert to really any backend in any format that you use to upload. So it doesn't just have to be queries, but these are the easiest to fit on a slide. Yeah, so this rule, as you can see, actually, you know what? I messed up and I didn't. I'll show you what this rule looks like. 1 second. Let me pull it up. So here it is. This is the actual rule that's being converted over here. So it just has the detection selection, image ends with PowerShell, and command line contains download. So this could be an example of a rule that might be useful to detect droppers. It's probably going to have a lot of false positives, but I wanted to create some rules that were like very minimalistic to kind of understand the general idea of what's going on. So as you can see, this rule here got converted into Splunk. I converted into Splunk, Elastic with the ECS schema, and ArcSight ESM with the Ceph schema. So you can actually, we'll get into this later of how to do this, but you can go to any schema or no schema, your own custom schema. It doesn't matter. Really, you can even have multiple field mappings. So if you have process executable.keyword and you have process.commandline.keyword, you can map to both of those, no problem. So the Sigma spec, yeah, so some of these are very obvious. The title is the name of the rule. The ID is kind of a global unique identifier for the rule. Related, it's not really used that often, but it can be used to point to other Sigma rules. The status is basically, is the rule experimental? Has it been thoroughly tested, embedded, or not, right? Description is more details about what the rule is and the purpose, the author, who wrote the rule. References, hey, if this rule fires, maybe if you look here, you'll have a better understanding of what it means. Or it could also be, hey, I pulled from this source to create this rule. Oftentimes, that's what it is. The most important ones here are underscored because maybe they're the most difficult to understand, and that's the ones I'll be talking about here. So yeah, we have the log source. So the log source defines the data sources the Sigma rule is meant for. So you have different ways to define the log source. You can define it as a category. You can define it as a product, and you can define it as a service, and you can actually mix and mingle. So you can have a product and a category, and you can have a product and a service as well. Sometimes some rules even have just a service, but I don't think any rule has just a product. Although there's nothing keeping you from doing that. I just don't think that it would be super useful to do that yet. So categories are kind of generic categories, right? Like, it's a firewall rule. Is it a web server rule? Is it meant for web logs? Is it a PowerShell rule? Is it a proxy rule meant for proxies? So probably the most common category that's used is process creation, because it's so rich, right? If you look at the research out there of MITRE ATT&CK and what data sources are the most powerful, maybe to get the best coverage of MITRE ATT&CK, process creation and process creation with command line is like, they're like the number one thing that you need. So yeah, it's super useful. So there's more rules for it. Anyways, so here's some examples that you might find in rules where it says log source Windows security. This would be the Windows security audit log. So if you're creating a rule that matches on 4625 failed logon attempts, you would use this as a log source. If you were writing a rule for, or you can also use this to look for rules too, right? Like we'll get into filtering later, but the log sources can be used to filter rules. So we also have process creation. That's again in here because it's very, very common and popular. And then you have web server logs. Sometimes, here's something interesting. Sometimes it's kind of confusing what log source is being used, and generally the more generic the fields the rule is using. So the image name, like command.exe, PowerShell.exe, and command line details, the actual arguments that were passed at runtime, are extremely common. And you could create a generic process creation rule for that. But if you have something like the current directory, which is details you might get in an EDR or via sysmon, you might have to be more specific. So generally, when we use these categories, like broad categories like process creation, what that means is, hey, this rule can be used across like disparate data sources that have similar fields. Whereas if you use product and service, like product Windows, service sysmon, you're saying, hey, this rule will probably only work if you have sysmon. That's basically the difference between saying Windows security, Windows sysmon, or just Windows process creation. The detection is the meat and potatoes of each rule. Really, it's actually the only part of the rule that you need. You could write a rule and convert it with only the detection section defined. That's the only part that's actually truly required in each rule. So here's two examples, really tiny rules. If you just wanted a rule that found every execution of PowerShell and you had process creation as a data source, this could be the rule for you. And then here's an example of maybe the more advanced rule using aggregations. So these are basically the two types of rules that you can have out there. Fundamentally, is one's does this field contain this, and the other one's does the field contain this, and did it happen X amount of times, or did Y perform it X amount of times? Those are basically the two different types of aggregations. Are did it happen so many times, or did something cause something else to happen 100 times, or X amount of times, or not X amount of times? You can do less than 2. So We're not going to go too far into like value modifiers or anything like that, but let me pull up the GitHub and we can explain a little bit about what's going on there. For the most part, they're self-explanatory, like ends with is ends with, contains is contains. No modifier here is equals to. So let's take a look though. The specification is more important if you're writing rules. And honestly, if you're writing rules, the pro tip is to find a rule that already exists that's similar to yours, if there is such a rule, and borrow that rule and just change what you need to get yours to work. That's the quick and dirty way to write any rule. It works 99% of the time, all the time. So yeah, here they are. Value modifiers. There's some fancy ones that you can do with identifying base 64 or base 64 offsets. But 99% of the rules just use no modifier or starts with, ends with, contains. And if you have sequences in your key sequences, sorry, I'm speaking YAML, but hold on. Let me pull up an example. So you could say, if you want to maybe make this rule more, blow it up, make this rule have more fidelity or reduce the false positives. Maybe you want where it contains download and system.reflection. And system.reflection is commonly used to expand the capabilities of PowerShell. And it's used a lot by offensive tools. So maybe that's something you're concerned about, is both of these words being anywhere in the arguments being passed to PowerShell. So you would do this. So command line contains, and then all of these must match. If you don't have that, then either could match. Yep, pretty simple. Fields. So the fields is something that is super useful, but people don't define it enough in their rules generally. Certain backends take these fields. Splunk is one of them, for instance, and they use them to help display interesting, to help the analyst, basically. So hopefully, yeah, it keeps popping up. I won't go down there then. But basically, you can see that this rule has fields defined: account name, IP address, and computer name. And it gets converted here to this rule, and it's going to table, account name, IP address, computer name. So when Splunk displays this data, it'll display it instead of the raw event, it'll display the interesting fields. So it helps analysts that way. And again, not enough people are using fields, in my opinion. So we should do that. If you write rules, include the fields. And then the level is important because it tells you the severity of the rule. It also tells you like a little bit about maybe the false positive. So the more critical, the further down the list you go to criticality, the less likely that there's going to be a false positive. So a low and medium rules imply like you're going to need some additional analysis before moving forward with this rule. So you can't just have it set up as an alert that needs to be immediately reviewed. Maybe you send it to a report with some stack counting, and an analyst takes a look at it once or twice a day and decides if there was anything worth triaging. Then you have high, which is basically an alert. It should make it to your SIM and be cased up and reviewed by analysts. And then critical rules should really be reserved for those high impact rules like WB admin deletes Windows backups, VSS admin deletes shadow copies, and shadow copy services were stopped all within 30 seconds on a host, which is indicative of ransomware. If there's something like that specific and that blatantly, obviously malicious, then this probably should be a critical. But most rules fall between low and high. And again, critical is one of those scenarios like if Sigma only contained true positive, no zero false positive rules, maybe everything would be critical, but you would lose out on potentially finding evil. So tags. Tags are important. You can tag whatever you want, but in the public repo, it's mostly used for binary attack to say, hey, this rule is related to this attack. What is very dangerous thinking is, hey, I have a Sigma rule from the public repo or from the threat detection marketplace that has a tag for, let me, I don't remember a tag off the top of my head, so let me just pull one up. I have the tag for, let's say, PowerShell. So let's say that you have the rules tagged with T1059 subtechnique 001. That does not necessarily mean that the rule covers you completely for that technique. You wouldn't say, I have this one rule, therefore I'm good to go. Because this rule, the example rule that we're going to be using a lot today, would technically fall into that technique. So I have the wrong tag here, but we fix that. T1059-001 and execution. There we go. All right, so we have attack.execution and we have this tag, but clearly this rule does not cover all possible PowerShell usage. So that's something that a lot of people get tripped up on, I think, and it's kind of dangerous thinking. All right, so got like 20 minutes to talk about actually how do I operationalize Sigma. So Sigma is a great repo. There's several hundred, I think over 500 rules in there now. They cover things like Mimikatz, identifying Cobalt Strike, identifying specific adversary activity and campaign activity, detecting living off the land binaries and all sorts of good stuff, right? Specific CVEs. So what's it? And it's all for free, available to you. Take a look at it, explore it. But it's only super useful if you know how to operationalize it because of many things. So basically, operationalizing it means using Sigma correctly and converting rules for your environment in an efficient as possible way. So how you do that, first you have to look inwards. You have to say, what data sources do I have? You probably have, almost everyone is sending firewall logs to their SIM. Maybe you have Windows security logs. Maybe you have Sysmon with process creation or 4688 with process creation. Maybe you have Sysmon sending network connection events. Maybe you have some web server logs, right? So first you have to identify the log sources. Then when you're using SIGMAC, you want to focus in on one, on a singular, on a singular log source. So I'm going to focus on web logs. And you might even say, I'm going to focus on web logs for my vCenter, which are in this specific index or something like that, right? You can get as specific as you need to get. And then you identify the appropriate backend. That's the easiest step of them all because that's just your SIM or log analytics platform or database, whatever you want to call it, the backend. Then you identify the appropriate SIGMAC configuration or generate it. a lot of times. You'll have to generate one, and then you identify appropriate backend options. These every SIM or backend has different options that you can pass to it to change how the translation works. And then you can identify the specific rules, or if you're using filters, you can say, for instance, for process creation, you could say log source equals process creation, and pull all process creation rules and translate them for you. So then you can then you just hit enter and run the conversion. And the step that's very important is verification. So you might run a few rules to test them to make sure they work per like log source type. So if you have log sources process creation, you might run like 3 or 4 rules through process creation, through your process creation SIGMAC and with the right, what you think are the right backend options. And then you should run them in your SIM and say, hey, yeah, looks like my SIGMAC is working for these rules, these rule types. So identifying log sources. This is basically just a list of what's available in Sigma today and in the public repo, but also in the threat detection marketplace. The threat detection marketplace has way more approved, or not approved, way more log source possibilities than the public repo does today. So the public repo for cloud has AWS, but we have in SOC Prime's TDM, we have stuff for Google Cloud, Azure, Office 365, G Suite, Zoom, Teams, etc. So there's a lot going on in TDM that hasn't, or the threat detection marketplace that hasn't made it into the public repo. And then you can identify your SIGMAC configuration. So if you're using a schema, and by that I mean you're using Splunk's common information model, or you're using Elastic's ECS, or you're using ArcSight's Ceph, you're in good hands because there's probably a configuration for you. But if you're not, then you must create your own custom schema using define your own schema using the SIGMAC configuration. So SIGMAC configurations are key to successfully using Sigma, like in operationalizing it. You have to put some work in to get a lot of benefit. So yeah, maps your field. So what do Sigma configurations do? Basically, they map your fields to local Sigma, and they also allow you to do certain things like you can for process creation. There's going to be examples that might make this more clear, but for process creation, you can say, hey, if it's a process creation rule, I know that all my process creation rules are sysmon event ID 1, so you can actually go in and retroactively add that as a condition to the rule. It's pretty cool. Identify the appropriate backend options. So every backend is going to have different options, and the way that you determine what they are is with this option argument backend help and the name of the backend, and that should document what all the possible backend options are for that backend. But this is actually pretty new, and it's something that has to be kind of manually done, whereas the other arguments that have lists and stuff that they can let you know are automatic. So it is possible that there could be backend options in the code that don't show up here, and the best way to know what really all the backend options are that are current is to probably just take a peek at the code and just search for backend in the backend that you're using, and it will. You should have some hits, and you can kind of review. It'll make sense if you have to do it. I'm not going to be exploring that in this talk though, but you'll see it'll be obvious what the backend options are in the code. It's in plain English there, but some examples of what you can do. So by default, XPack Watcher will write as the action. If you're not familiar with XPack Watcher, it has actions. You can send an email. You can send it to re-index the event. You can create a JIRA ticket. You can do all sorts of crazy stuff. But the default action, if you don't send it a backend option, is to write it so that it sends an email. But if you want to re-index that rule, then you just use the backend option and say, hey, don't send it to email, send it to an index. You can add, for Splunk, you can add comments to rules. We'll be doing that one. And specify indices, etc. So some backends have a lot. XPack Watcher probably might have the most. Some have very little. It depends on the backend. And you can provide them as a config file. And if you're an Elastic user, here one more time. If you're an Elastic user, go ahead and read this wiki page that was written by SOC Prime's Nate Guageni, who's not here this month. But you can get a better understanding of what backends you probably need to use by reading his explanation here. So highly recommend doing that if you're using Elastic. So let's open up PowerShell and start giving some examples of this stuff. So wrong. Let me just blow it up a little bit. Okay. Hopefully that's easier to read as we go along. So in here I have, so this is the Sigma repo that I copied off of GitHub, and I'm going to be operating it mostly out of this rules directory to write some rules. So let's take a look at my example rule. Sorry. So here's the example rule that we're going to be working with. It's familiar because I already pulled it up a bunch. But basically all it does is looks for a PowerShell .exe with download and the command line details. And if we wanted to convert this rule for Splunk, you just use Python 3. That's important. Python 2.7, 2.8 don't work with SIGMAC. You have to use Python 3. Anyways, run SIGMAC against that example rule, which I have in this directory. I'll be passing it the config Splunk Windows and the target Splunk. So the config Splunk Windows, let me just get rid of something here. If you just pass it a target, SIGMAC will warn you and say, I need a configuration. I don't know what to do. And it'll give you an example of the configurations that are available to you. And if you want to read, kind of look into each one to decide, like, is this configuration for me? You can just go to CD. You can CD or open the config directory, and they're all in here. So Splunk Windows is here. So if we wanted to take a look at it, we could just do open it up in whatever editor or file viewer that you want and take a look at what's going on. So yeah, we'll I'm not going to explain what's going on in this one, but I'll explain what's going on in a custom config here in a minute. So yep, if you run it, oops, sorry, I need to go back. And give it that config, Splunk Windows, and it will convert it. So you can see here that it converted it to what's basically the base sysmon fields. But if we had our own fields and we had our own indices and we wanted to be more specific, we would use our custom config. So let's take a look at a custom config that I wrote. Man, why are you not copying? and jam it then. Nope. Okay, so here's a very simple custom config. So this one, I wrote it for process creation from Windows event collectors being, so Windows event collector, if you use that, it's probably going to show up in XML, and Splunk treats XML different from just reading the event log locally with the Splunk forwarder. So here's the two possible, all right, let me slow down, getting ahead. So you define the backends that this config can be used for here. And then you start defining the log source that this config uses. So you can have multiple log sources here, but in this one, I'm just using process creation as an example. So the conditions section of here is where you actually can add you can add logic to the rules. So this is where I'm going to go ahead and I'm going to add, hey, I have 4688, which is process creation and the Windows security log, and I have sysmon event ID 1. So I'm going to pass both of these as a multi-field mapping, and then I'm going to add, hey, I want, let's change this to sysmon. I want the index to be win event log, or maybe my sysmon data is in different index, so I'll call it win event log and sysmon. So both indices will show up in the rule, and I want to specify the source for whatever reason. Just another example. So you can again add conditions. So if this configuration sees process creation, it's going to add these values to the rule, and if it sees these fields, event ID, image, it will remap them to event code and event ID, and image to new process name and image. So let's take a look and run it with our custom config. Okay, doesn't want to paste for some reason. That's okay. Just going to take me a second longer. Oh, okay. Sorry, there's something wrong with my USB hub during this talk, so it might do that again here. There it goes. Seems like no matter how much I try to not fail at these, something silly always happens. All right, so this time I'm going to pass it the custom config that I saved in the config directory. So that's where it default looks, but you can pass it a path as well if it doesn't exist there. And I'm going to run it. And here's the output. So now you can see, instead of just including image equals PowerShell, command line equals download, we have a lot more specified here, and the rule will be more efficient in our sim, right? So we have use these event codes, use these indices, look for this source. So this rule went from being pretty expensive, huge cross indices search to being very specific. I think the benefits there are clear, and that's the power of SIGMAC. So there's a lot more you can do with SIGMAC. You can stack configs. So I have another config here that we'll take a look at. Yeah, so here's config B, and we'll open up the other config that I want to use. So someone has written a config that's generic to sysmon. And so we can actually pass 2 config files, and the way it decides which one to use first is via order. So the lower the order, this one will be executed, and then this one will be executed. So basically, the YAML kind of gets manipulated by this, and then whatever it was manipulated to here, this configuration will see those manipulations and act as if it was a Sigma rule right out of the repo, if that makes any sense. So it'll be changed here, and then the second configuration will be run against it, and it will change whatever this made into the additional things that you define here. So this could be useful, like if you're if you're like an MSSP who has a schema that you want your customers to use, but maybe not everyone is using the schema perfectly. So maybe you have a secondary configuration or tertiary even configuration that goes from the Sigma schema to the schema you want them to use to the actual schema that they're using or something like that. So yeah, so we can pass it all these at runtime. This. And it will pop out the rule. So let's just go in here and make a change so it'll be more obvious maybe what's happening. So if we did something crazy, we might say change this to event ID 3, who knows? And then you can see that it goes from, this is changing from process creation to rewrite those fields to Windows sysmon. And then this one is looking for Windows sysmon and making the changes. So the first rule is saying, if it's process creation, do this. And this one is then saying, it's saying if it's process creation, rewrite it to Windows sysmon. And then this config is working because it's named Windows sysmon. And we could run it. You should see event ID is 3, but we could, and then this one, we could make the change again to change one of them to them back. So this should. Oh, yeah, there we go. It was in there. I just missed it. So yeah, you can. Yeah, there it is. I just missed it. My eyes missed it. Yeah, so you can change it back or rewrite it or add it as another condition. So just something to be aware of with the stacking configs. The more complicated your environments are, the more likely you will want to do something like that. And then finally, or not finally, there's 2 more things I want to cover. We have filtering. So if we go to my rules, take a look at the rules repo, you'll see that there's example rule and example rule filter. They're both identical except example rule filter, instead of saying product Windows category process creation, it says jumbo wumbo. So if you, in Sigma, a common thing to do is to say, I want all the rules, right? So instead of passing it to a specific rule, you might say, I want to do it recursively. So to do that, you just pass it recurse, and then I'm going to recursively look in this directory rules. And let me just change it back to the regular rules. All right, so now it'll do, it'll convert both rules. Okay, so it's doing the process creation category rule, and it's also doing the jumbo wumbo rule. But if we just pass it filter, log source equals process creation, it should do only one of the rules. Yep. So it skipped the jumbo wumbo rule. So the filter is really important if you're like recursively running a bunch of rules, because different rule types are going to require different sigmax. So you want to match your, or could require different sigmax, I should say. You could write like a catch-all sigmax configuration, probably, but you'll probably instead be creating multiple ones, I would imagine, or often using multiple ones for different use cases, different customers, etc. So you can just say, with the filter, you can say, hey, if it's process creation, run this config against it and give me what I need to move on. And finally, let's talk about the backend options. So to get those, you just type Python 3 sigmac and then backend help, and then the name of the backend you want help for. So in this, I'm going to be using Splunk as an example. And you can see that there's only one here, which is role comment, and it says prefix generated query with comment containing title. Okay, so if we wanted to pass that backend option, we would just do backend option role comment. And this one doesn't take any argument. It's a true or false binary thing. So we can just say, we can just pass it the backend option and it'll add it. So you can see that it added the comment here when I pass it the backend option. But there's, it really depends on the backend. Let's look at XPack Watcher. It's going to be dirty. Hey, look, I know it's kind of lined up here. Yeah, so it takes like 20 possible backend options that you can pass it, because there's so much you can do with XPack Watcher, and so much that can be different from your environment to the next. So you can pass it at runtime, or if you look at the rule repository, you can learn how to create a config file and pass a bunch of them at once via the file. So that's it. Let me take a look and answer any Q&As. Can Sigma be used for real-time detection? How is the performance? It depends. So I would say Sigma, it cannot be used for real-time detection because it can, but it can't. It can be used for real-time detection because it can be translated into backend queries and rules that are real-time, if that makes sense. So it can be used for it can be used for real-time detections, but it by itself cannot. Like, you can't just take the Sigma specification, a rule written in the Sigma specification, and deploy it to any SIM yet. The performance, it depends on the rule. Some rules are noisy, and some rules are not. Some rules are really noisy, some rules are not. Some rules are expensive, some rules are not. In the SOC Prime's TDM, we have metrics that we tag our rules with. So if we take a look at this, you can see, wrong tab. You can see the severity, action, pain, and impact. Impact is SIM impact. So how expensive is this rule to run? So a 3 is it's not expensive at all. A 1 is it's pretty expensive. It's the scale is 1 to 3. Can I correlate different log sources within the Sigma rule itself, or is it easier? Is each rule only for one dedicated log source? Yeah, so you can have multi-YAML rules, something I didn't get into, but they can work across disparate log sources. They're more expensive. Honestly, personally, I don't like doing this. Let's see if we can find one. Because to me, it's not as efficient. Let's see here. I can find one easily. There we go. Oh, that's a test rule. There we go. Woohoo. All right, so here's an example of a multi-YAML rule, and it contains this is strange, yeah. Oh, here we go. Yeah, that's strange. It doesn't this really strange way to write that rule. Okay. Bad example. It's a multi-YAML rule without there we go, without multiple log sources. So this one contains process creation and file event, and so yeah, you can write across different log sources, and you can write an aggregation off of these conditions. So you can have a condition that affects. You can write your condition so that it uses both of these, and you could say like a common example might be if you have account names between two things. So if you have Azure Sentinel logon and you have Duo that you're using and the usernames are the same, as long as there's a field that's similar, you could write a correlation between the two. But it's really limited, and there's no way to like manipulate the data today. So if one of them is using an email address and one of them is using the SAM account name, and in Splunk or in Custo, you could manipulate the email address to become their SAM account name. That's not something you can do in Sigma today, if that makes any sense. There's a match. How does SOC Prime display the alert? Is it a separate dashboard? Okay, so SOC Prime is not a SIM. We don't display any alerts. You borrow the rule from us. So you go here. Let's say we want to deploy this rule if it wants to load. Oh, that's why. It was like, dummy, you're already on the rule. Okay, sorry about that. So the Sigma rule exists here for anyone if you want to download this and run your own SIGMAC, or we do some translations for people automatically, and you can even pick different schemas if you need to. You can define some custom backend options, etc. So yeah, you would take this rule, deploy it, and then in your existing SIM, that's where everything would be displayed. That makes sense. And are there any further? Oh, here we go, new questions. Are there any out-of-the-box supported SIM backends, e.g. Splunk, Elastic by Sigma? Yeah, there's a bunch. So if you want to know all the backends, I think they're all listed here somewhere. Yeah, here we go. So here's the targets or the backend. Splunk. There's a bunch of Elastic in here. So if you're familiar with Elastic, DSL is different from KQL is different from Lucene, is different from their detection rules. Here's PowerShell, ArcSight, Sumo, Humio is not in here. So I'll say this, and out of the box from the public Sigma repo, there's these. If you take a look at SOC Prime, Humio is in here. So we have backends that haven't been released publicly yet, that anyone can use if you have a SOC Prime account. So it's different. If you're talking about the public Sigma repo or the public SIGMAC, it's different from SOC Prime's. SOC Prime supports like most, if not all, of the public ones, but the public repo doesn't have all of SOC Primes. But generally, I would say that after we work out all the kinks and they become mature, it takes a few months, and Florian and Thomas have to review the backends as we submit them and stuff like that. But generally, they make it into the public one eventually. Can Sigma work with Yara and vice versa? So Sigma can work with Yara L. I don't see any reason why. No one that I know is doing it today, but I don't see any reason why you couldn't express a Yara rule, a basic Yara rule in Sigma and translate it. Does the Neo23XO account belong to me? No, that's Florian Roth. He is the primary account owner or the primary owner of Sigma. Using Sigma and CI are any proper frameworks, methods? So every Sigma rule is tagged with MITRE attack. So again, if you're doing CTI and you're concerned about an actor and you know what techniques they're using, you could say, let me pull up all the techniques. Let me create a filter. You could use a filter to do this, to find rules that contain those tags. SOC Prime makes it easy by, see if I can find, oh, sorry, let me get out of there. SOC Prime makes it easy by having the MITRE attack view. And so, ooh, fancy. Yeah. You can use this to do all sorts of CI and tag it to actors and all that type of stuff. There's tag and the threat detection marketplace, there's tagging for specific actors. There's a million ways that you could tie this to the threat intelligence, especially using the threat detection marketplace. With the Sigma, it's not as easily like laid out for you to find them, but they're there. And for the most part, the rules in the public repo are in TDM because the licensing allows that. So there's APT specific rules on this APT folder, but there's also other ones listed. Let me just pull. Sometimes they'll have ones that are named to specific, that one failed, to specific campaigns in here. So yeah, when APT 29 think tanks. So if you were concerned about the think tanks campaign, then you could pull this rule. Can a Splunk SPL query converted to Sigma format? There's no automated way to do it, but you could manually do it today. I'm sure there's people out there working on a way to automatically convert rules from existing SIM languages to Sigma. And how do you testing rules to verify is working correctly? Good question. So when you're first testing rules in your SIGMAC, the best way to kind of get an understanding is to write use cases that are blatantly obvious and noisy. So process process name is command.exe. Run the SIGMAC, run it to Splunk SPL, for instance, or Elastic Lucene. Paste it into your SIM or database and see if you get hits. So then at least you know the SIGMAC is working. To know if the whole chain, I mean, that's a very hard question to like answer in a quick way, because there's events happen from birth on the device that the event occurs on. It has to go through however you're getting it to your SIM. It could be going through a broker. It could be going through WEC. It could be coming from a third party cloud provider that you have, making it into who knows what kind of chain of events to get into your SIM. So like that's the place that you should start. Like, am I getting the data that I think I am? And is it the schema correct? And then once you have that kind of figured out, then like knowing if the Sigma rule is going to work becomes more obvious, because you know what kind of data that you're getting. And that's probably the main reason. There's probably two main reasons why Sigma rules fail, besides just the logic being incorrect. The one is you assume that you have a data source that you don't. Like Sigma, when you pull Sigma and translate it and put it into your SIM, it doesn't magically create a data source for you, right? It relies on the data being there. So sometimes people deploy stuff and I don't know, they think like the Sigma rule is magically going to create this data source that the rule requires, and it's going to work. And then the second thing is the schema problem. So if you call your field command line details, but Sigma converts it to command line, it's not going to work. I receive a lot of false positive alert. Sorry about that. It's hard to diagnose maybe what's going on there. But again, the big thing, if we go back to the first slide of Sigma, expectations. False positive free library does not exist. And then the other part is look at the severity of the rule. If you want only true positives, go for critical and high. If it says lower medium, that implies that you're going to have to be doing additional analysis. If you have a high rule, or high rule, sounds like a Legend of Zelda game, right? If you have a rule as level high, and it's getting a lot of false positives, maybe there's some tuning that you can do for that rule, maybe not. So something that's dangerous to do with Sigma, I would say, is deploy rules without testing them and seeing if they're appropriate for your environment. If you just deploy everything, then I would expect to get smacked by false positives. Not saying that you're doing that specifically, but these are the common errors. Best case practices while creating. How to choose case while writing Sigma rule, like limitation or data source criteria, etc. So if you want to know best practices for writing Sigma rules, I highly recommend joining the developer program. There's special talks that I do just for developers where I talk about all of that, and you'll get access to additional information there. But I'll give you some quick examples of things that happen a lot. Is as I think the person is kind of a leading question with field names. So if you have command line in Sigma, if you have a Sigma rule and you write one and it says command line, I'm trying to equals hello. Or you know what? Let me just go back to the example rule because that'll. Where are you at? Example. There we go. Let's say that we have command line here, but oops, I accidentally left it under case. yeah, you're going to see that the translation should fail. Yeah, so it didn't. It's kind of a bad example because they're literally the same thing. Just one of them is capitalized and one of them isn't. But this should be capitalized. Command C is capitalized, L is capitalized if it was done correctly. So that's what that person is alluding to. Basically, it's common in Sigma to say forget to capitalize these things, or it'll be more obvious here. Hold on. Let me do it to Elastic because that'll be more obvious with ECS. What am I doing wrong? ES, DS? I think that's DSO. There we go. No, all right, hold on. ES, ESQS, what's going on? Maybe I have the wrong config. Maybe it's just modules. Yeah, that's what it is. Hold on. You did to yell at me and tell me what the configs are quick. Oh, I see what I did. I'm done. Okay. Yeah, see, now this is the bad version of it where it's just putting into this command line field. But if I change it back, it'll go into the correct field now. So in Python with ECS, it should be process.args or process.command line. Those are the two ECS fields that contain process arguments. And if the person left it uncapitalized as the field name, it gets converted. It doesn't get converted through the SIGMAC at all, and it just shows up as whatever the original field was in the Sigma rule. And if they do it correctly, it gets translated to ECS correctly. How much research and time was required to write the VMware vCenter rule? I think this might be coming from Nate Guajani, if he's watching. That rule took about 10 minutes because it was so simple. Do you have Sigma rules for web attacks? Yep. They're in TDM. They're also in the public repo. So if we, sometimes the more trivial the exploit, the easier the rule is to write. And sometimes we cannot write any Sigma rule for an exploit unless you're like, if that makes any sense. You can't write a Sigma rule for an exploit if there's no data source for it, right? So if there's no log being generated, then you're not going to be able to write the rule. If there's a log being generated somewhere and it's specific enough that you can reduce false positives and not have the rule blow up, then it's possible to write the rule. But you could, we've done this for customers, is write sigmas that are alerts on alerts, basically. A lot of the cloud content can be like that, not all of it, where we're basically, hey, Google thinks this is bad, you should take a look at it. But if there's no more questions, we'll call it good. This was a long one. So thanks for sticking on. 40 people or so stuck all the way to the end from the original 100 or so. So that's awesome. Hopefully this has inspired you to take a look at the project for yourself and maybe operationalize it a bit. So maybe we can spend some more time. Maybe I can go in a little bit deeper on, best practices or stuff like that in the future. So if you have any recommendations of more things you would like us to talk about, we'd gladly accept them and try to do our best to cover them. So don't forget the challenge and have a great rest of your week. Thanks.